Across vast construction sites, a silent battle rages against the construction industry's reliance on fossil fuels. Imagine a world where colossal excavators and 200-ton mining trucks operate with near-zero emissions. This vision is taking shape with hydrogen, an emerging fuel being tested to power some of construction's biggest machines, promising to redefine how we build our world. This isn't just about cleaner air. It's about improving efficiency, addressing logistical challenges, and contributing to a sustainable energy future. The stakes couldn't be higher. This is Hard Hat Industries, where heavy machinery comes alive. For decades, diesel has been the undisputed king of construction. Its high energy density, ease of transport, and established infrastructure made it the go-to fuel for everything from compact track loaders to gargantuan draglines. But the crown is slipping. Emissions regulations are tightening globally, fuel prices are volatile, and the industry faces immense pressure to decarbonize. The question isn't if diesel's reign will end, but when and with what. Enter hydrogen. While it's been touted as a clean energy solution for years, its application in heavy machinery faced immense skepticism. How do you store enough volatile gas on a massive machine? Is it truly efficient enough to match diesel's raw power? These were the questions that haunted engineers. But the answer, surprisingly, is not just about a cleaner burn. It's about a fundamental re-evaluation of energy delivery. Here's how these hydrogen engines work, and why they're revolutionary. There are two primary ways hydrogen can power heavy machinery. The first and arguably most promising for large equipment is through hydrogen fuel cells. Think of a fuel cell as a continuously operating battery. Instead of storing a charge, it generates electricity through a chemical reaction between hydrogen and oxygen. Hydrogen gas is fed into the anode, and oxygen, usually from the air, enters the cathode. A catalyst at the anode separates the hydrogen atoms into protons and electrons. The protons pass through a proton exchange membrane to the cathode, while the electrons are forced to travel through an external circuit to reach the cathode, creating an electric current. This is the power that drives the machine's electric motors. The only byproduct? Pure water and heat. This direct conversion process can achieve energy efficiencies of 50 to 60% in ideal conditions, compared to modern diesel engines, which can reach efficiencies of up to 40 to 45% in heavy machinery. This efficiency edge makes fuel cells a compelling option for meeting the power demands of construction equipment. The second method is hydrogen internal combustion. This involves modifying or redesigning traditional diesel engines to burn hydrogen directly. Unlike diesel, hydrogen combustion produces near-zero carbon emissions, though it can generate nitrogen oxides due to high combustion temperatures. This approach leverages existing engine architecture, potentially easing the transition for some manufacturers. However, the fuel cell approach is generally favored for its zero tailpipe emissions and higher efficiency, particularly for the scale of power required by the largest machines. The tension within the industry is palpable. Companies are investing heavily in research and development, knowing that the wrong bet could mean obsolescence. Will hydrogen become a cornerstone of sustainable power? Early pilot projects suggest a promising future. The most obvious benefit of hydrogen is its zero-emission output when used in fuel cells. The only byproduct is water. This is a game-changer for air quality on job sites and for global carbon reduction targets. But the narrative around hydrogen often misses the deeper, more transformative benefits it offers. Think about uptime. Refueling a massive diesel mining truck can take significant time, and maintenance on complex diesel engines is a constant drain. Hydrogen refueling, when supported by advanced infrastructure, can take as little as 5 to 10 minutes for certain systems, though it may not yet match the speed and simplicity of diesel refueling in all cases. Furthermore, the simplicity of fuel cell powertrains, with fewer moving parts than traditional engines, promises reduced maintenance costs and extended operational lifespans. This isn't just about saving money, it's about maximizing the productive hours of machines that cost millions. A CAT 797F, one of the world's largest mechanical drive haul trucks, can carry over 400 tons. Its diesel engine is a marvel of engineering, but imagine that same hauling power delivered instantly by electric motors fed by hydrogen fuel cells, with potentially less maintenance downtime. This could lead to a paradigm shift in operational efficiency, translating to higher project completion rates and lower overall costs. Another advantage is the potential for energy resilience. Many nations rely heavily on imported fossil fuels, making them vulnerable to geopolitical shifts and volatile oil markets. Hydrogen, produced through electrolysis using renewable energy, could offer a pathway to localized energy production. For remote mining operations or massive dam construction projects, generating hydrogen on-site using renewable energy could simplify logistics, though the infrastructure for such systems is still in its infancy. The question is, how quickly can the infrastructure to support this new hydrogen economy catch up to the machines themselves? And what hurdles still stand in the way of widespread adoption? The shift to hydrogen in heavy machinery is a global effort with significant implications. From pilot projects like Anglo-American's hydrogen-powered mining trucks in South Africa to collaborations between major manufacturers, the momentum is building. Companies are investing in R&D and early-stage deployments to demonstrate the viability of hydrogen in construction and mining. Let's take a look at some of the key players. Caterpillar, a titan in the industry, is exploring hydrogen-powered solutions as part of a broader strategy that includes electrification and alternative fuels. They are researching hydrogen combustion engines and fuel cell power systems for their range of equipment, from excavators to large mining trucks, aiming to integrate hydrogen into their platforms alongside other technologies. Komatsu, another industry giant, is already testing a hydrogen fuel cell mining truck, a modified version of their 930E electric drive truck, in collaboration with Cummins. This partnership brings together Komatsu's expertise in large-scale machinery with Cummins' leadership in power generation and fuel cell technology. The goal is to prove the viability of hydrogen fuel cells in the most demanding mining environments, paving the way for broader adoption in construction. Liebherr, known for its powerful cranes and excavators, is also heavily invested. They've showcased concepts and are actively developing hydrogen-powered internal combustion engines for their construction machines, alongside exploring fuel cell applications. Their focus is on ensuring their hydrogen solutions deliver the same robust performance and reliability that customers expect from their diesel counterparts. Hyundai Construction Equipment is making strides as well, having showcased early concepts for hydrogen fuel cell excavators and forklifts. These prototypes signal their vision for a hydrogen-powered future, though commercial deployment is still on the horizon. This commitment from major manufacturers signals a critical turning point. They are adapting strategies to include hydrogen, driven by the potential for a sustainable future. The industry's ingenuity is addressing the energy challenge, with even incremental improvements bringing significant benefits and the vision of cleaner, quieter construction sites motivating change. The profound impact of this shift is clear. This isn't science fiction. It's in development. The challenges are significant, but the potential rewards, a cleaner planet, more efficient operations, and a resilient energy future for heavy industry are too great to ignore. We are witnessing the early stages of a new era in construction, powered by an invisible force with the potential to redefine what's possible. We began by examining the construction industry's battle against fossil fuels. Now, hydrogen is emerging as a contender, offering not just emissions reductions, but potential efficiency gains through fuel cells and combustion technology. Major players like Caterpillar, Komatsu, Liebherr, and Hyundai are pioneering this future through research and pilot projects. The path ahead holds challenges, but the heavy machinery industry's resilience means they're uniquely positioned to lead. The world stands to gain. Thanks for watching Hard Hat Industries, your source for serious machines doing real work. If you like this, go ahead and hit like, subscribe, and turn on notifications so you don't miss what's next. Until then, keep your head down and your gear running.